I'm Rebecca Bishop.
And I'm Matt Bingham, and our project is the chicken tender. So Rebecca, tell me about this chicken tender. What led us to create this?
Well, I actually have chickens, and I have to be home every night to close up the coop. So this is an automated process that would allow me to not be home at nighttime when the chickens need closed up, because if you don't close them up, they could get attacked. You know, you want to keep them warm and safe inside their coop. So this is mimicking a door, and it will be open during the day. Our light sensor will decide when it locks with this electromagnet, and there's an RFID reader that's not on here right now, that all the chickens will have a tag on them, and if they get left out at night, or if the clouds cover the sun and the sensor tells the magnet to lock, the tag on the chicken will trigger the magnet to open or unlock, and then the servo will open the door.
That's interesting. Tell me about how you're going to control some of this stuff.
It's all through the Arduino Uno R3. And we have an external power supply, and we will go through this breadboard with 12 volts and 5 volts. We'll have indicator lights. The green light is when the door is unlocked, and the red light is when it is locked. And that means there's power going to this magnet right here, and it will close that and hold it tight. And so even a strong raccoon won't be able to get in here.
Tell me about this fan over here. That's pretty interesting.
Yeah, this fan is just there for an accessory if the chickens need it to blow bugs off them, or if they need an exhaust fan. It's pretty straightforward programming on that one, but you can talk about that some.
So one thing we actually had discussed with this, so this is just one of many different extra modules that we had planned on making here. We're just going to include the one in our initial code for now, just to kind of show that this is a modular system. This is designed to accept all kinds of extra just things. We had actually initially thought about having feeding, watering. There's having like a buzzer when they come in and out, so that you didn't have to like physically look at it to see if it's being engaged. There's several other things. I mean, you can implement many different things with this.
And obviously this is a small scale, so we could put a garage door opener on it and control it even, and have a big door open and close. I mean, it's endless. It's up to the imagination.
The larger scale version of this would be kind of like, so this door, instead of being represented this way, what the thought was is some sort of a swinging door, and then the servo will activate again, or the servo will bring it down to the home position when it's in its night mode before it locks it, so that we don't squish the chicken. We don't want to do that. So let's, without any more wasting time here, let's go ahead and jump into the code. So
fun stuff.
we have all kinds of initial stuff we're doing here. So we're going to include two libraries that are not standard. And so the servo library, it's a common library, but it's not just baked into the Arduino all the time. And then this fancy HP BH1750 library, this is going to control our photo sensor. We need this one to even be able to interface with it. All these integers are just kind of defining our pin numbers. We're going to initiate our servo, and we're going to initialize the pin. Like, this is actually all taken care of inside the library as far as initialization. We actually have to hook it up exactly to the pins that it needs it to be on. All right, so in our setup, we have the serial communication is going to run at 9600 baud rate. We're going to attach the servo to pin 9. On the Arduino R3, it only runs on pin 9 or 10, so we just picked the first one. Photo pin sets itself up with these 3 commands here. And let's check out our code. So the mode detector, this is a very important one. This particular function runs repeatedly, but we're only going to have it check the mode every 10 minutes. So what we mean by mode is we're going to use the light sensor to detect whether it is bright enough to be considered day mode, or if it's dark enough to where it's going to use night mode instead. You can see it's going to generate some sort of just a float number, so just a long number. We don't know how big the number will be necessarily, and it'll definitely have a decimal, so we need to have a float. And it's going to read it, and here's basically what I just said here. If we If it's below this value or greater than this value, we're gonna jump to the daytime function or the nighttime function. Otherwise, we'll just go ahead and reset that photo pin and then read it again. All right, so here is our, let's go ahead and jump down to night mode first, actually. The day and the night mode, because this is used inside night mode. As you can see, we wrote a lot of code and reorganized it throughout. Here's day mode up here, actually. So during the daytime, it's a lot simpler overall. The cycle number that I'm starting here is basically just to create a timer. And while this cycles up, so it looks like it's a high number, but this thing performs 16 million calculations every second. So it's really not that high. While it's counting up, it's gonna constantly keep that fan active. It's gonna make sure that that door is disengaged. And it's gonna go ahead and cycle up to make sure that this number, it doesn't just run it forever. And then at the end of that particular block, we're gonna go ahead and go right back to the mode detector, which is gonna test, again, what the light sensor or light levels are, and go ahead and make a decision based on that. Now the special one here is the night mode. This is where we're actually doing a lot more of the heavy lifting. Once again, we're gonna start a timer. We want to check that light level every 10 minutes. So while it's cycling, we're gonna make sure the fan is off, because at night, we don't necessarily need the exhaust fan. We're gonna go ahead and make sure that the red indicator light's on, and we're gonna jump up to our chicken detector function before we go back to the mode detector. So if we go way up high, it was the second one, I do believe, right here. Okay. So inside this particular function, we're gonna go ahead and declare an integer that is basically whatever the state of the RFID pin is. So an analog values using with the Arduino is anything between 0 and 1023. So we're gonna go ahead and, if it's reading low, on the low half of that, we're gonna go ahead and consider it a 0, is basically what we need to do. We need to convert it from analog to a digital signal. And that's the idea here. So the analog signal is less than half. We're gonna go ahead and run this loop. So we're gonna go ahead and disengage. So what this means actually, if the RF value is less than this number, that means that there is a chicken with its RFID tag near the RF sensor. When that happens, we're gonna go ahead and unlock the door. We're gonna put on a green indicator light, and then we're gonna move that servo to open that door for the chicken. We're gonna continue that for about 10 seconds or so. We're adjusting the actual values because it calculates so quickly, it's kind of hard to get a consistent timing sometimes. Let's go ahead and scroll down some more. And go ahead and delay for just a moment to give that servo a little bit of time to get to where it's going. Otherwise, if the RFID is not sensing a chicken, we're gonna go ahead and make sure that that indicator is off. We're gonna make sure that that servo is in the home position so that door is closed. And again, we're just gonna wait for a minute. So just because we told the servo to close doesn't mean that it's actually closed. This is our chicken safety mechanism right here. We're gonna read the position of that servo and make sure that it is within 10 degrees or so of the actual position we want it to be. And if it is, we're gonna go ahead and engage that electromagnet. The electromagnet works at 130 pounds of force, so we wanna make sure that there's no chicken there before we engage that. Otherwise, if it is not to that point yet, we're just gonna tell it to do the same thing. Go back home, wait a little bit, and then go ahead and engage your electromagnet. So, overall, we have just a tiny bit of code at the very bottom here, basically just to run all this stuff, so a little farther. So this is our main function. So while one, that basically is just an infinite loop. I just want it to run literally forever. If this thing's on, this is what it's doing. It's gonna run our mode detector. Mode detector, once again, checks the light levels and chooses day or night mode, depending on what it senses.
All right, well thanks Matt, that's great information, and shout out to Dr. Shin. This is our mechatronics class for 470, so that'll do it.
Thank you for watching.
Questions in the comments section please, thanks.